Alright, hello everyone. So welcome to my new video. So what we are going to do in this video, we are going to continue our discussion from last video. So we have an integral to solve. So let's try to use LIAT rule. So I'm going to show you how this fails. So do we have two functions here to choose u and dv? Well, we can think that we have one here, right? Just like the trick that we use when we are integrating natural log x, remember? So we can think constant as the algebraic function and we have a trigonometric function. Okay, so let's choose our u to be 1 and dv to be sine square root x. Now what do you think? Well, can we get v out of dv? We have to integrate sine square root x. Now that's what we are going to do, right? That's what we have to do in here. So that is a very poor choice for u and v. Okay, so that doesn't work. Then can we switch u and v? Can we switch the choices? Now one advice I can give you is that be careful with switching your choices u and dv when you see that integration by parts doesn't work, if you think that your choice of u and dv are wrong. You have to be very confident in LIAT rule. So if you are very confident that you use LIAT rule and if you think that your choices are wrong, that means you have to rethink about the problem, not switching the choices. But I want you to switch choices here and see what you're going to end up with, okay? Because it's good to see where you can get a problem wrong, okay? So try to see it by yourself. Why can't you switch choices here? Switch choices will be like u is sine square root of x and dv is going to be 1. Well, both of them are easy choices. I mean, if you integrate v, you're going to get x, right? If you integrate 1, you get x. Okay, so you can differentiate sine square root x, but think, why can't you proceed from here? Try to use the formula and see what's going on there. But okay, I already said that doesn't work. Then how do we integrate sine square root of x? Well, let's use u substitution or w substitution. Let's call it that. Okay, integration by substitution. So w is going to be square root x because that's the inside function, that is inside sine. Now derivative of w with respect to x is, so this is x to the half. So if you differentiate x to the half, you get half x to the half minus 1. So half x to the negative half, which we can write 1 over 2x to the half. So I make this power positive by taking it to the denominator. So this is 1 over 2 square root x. Okay, now the other problem here with integration by substitution here is that we know from integration by substitution that inside function and its derivatives both should be in the integral. Well, we have the inside function, but the derivative, you can't see it somewhere else in the integral, right? You don't see 1 over 2 square root x in the integral. So do you think we can't use integration by substitution? I don't know, right? So there are problems with, you can't use integration by parts, you can't use integration by substitution. There's hesitation everywhere. Now that means this is a problem, that you can't use integration by substitution right away, you can't use integration by parts right away. No matter which technique you choose, it's damn hard. So how do we solve this integral? Let's see. Let's proceed with integration by substitution and see what we get. Okay, let's do not panic here. If you use integration by substitution, this is not SW, sine W, right? Because square root x is W. Now what is dx? Oops. So dw over dx is 1 over 2 square root x. So dx is actually 2 square root x dw, right? So let's replace that. 2 square root x dw. Now we know we can't have two variables in the integral at this level, right? Mixed variables, x and w. So how can we get rid of square root x here? Well, square root x is w, right? We can go back and get the help from the substitute, right? That's something that we learn on the integration by substitution, tricky problems. Well, this is a tricky problem. So this is 2 square root x is w, so 2w sine w. Okay, now can we at least integrate this new integral? We can integrate this new integral by what? Using integration by parts and using LIAT AT rule. Yes, let's see that. So here I'm going to choose U to be 2W, not DW, dV to be sine W, dW, because 2W is an algebraic function, this is a trigonometric function, so algebraic comes first, so 2W is U. Okay, now du over dw is, if you differentiate 2w you get 2, if you integrate dv you get integral of sine w is negative cosine w. So du is 2dw, so we have all the tools we need, right? Okay, so let's use the formula. Formula is uv minus integral v du. Okay, so here u is 2w, v is negative cosine w. Don't get ahead yourself. Okay, minus v is negative cosine w and du is 2dw. So let's write 2 here. Negative 2dw. Okay. All right. So let's see what we get. Negative 2w cosine w. Here negative positive 2. We have to integrate 2 cosine w. Now can we integrate 2 cosine w very easily? Absolutely yes. So this is negative 2w cosine w. If you integrate cosine w you get sine w. 2 sine w plus arbitrary constant c. Now let's replace what is w. Well, w is square root x cosine square root x plus 2 sine square root x plus c. Okay, so this is the answer. See, again another problem where you have to use integration by substitution and then integration by parts. So it's hard. This is a hard problem for both techniques. Okay. All right, so let's do another problem. Now the problem that I'm going to do here is very tricky. Okay, you're going to enjoy this. This is natural log x square over x cube dx. Okay, right, when you look at this integral, well, we know we have natural log x as an inside function and derivative of natural log x is 1 over x. So we can see 1 over x cube is somewhere else in the integral, but we can take out a 1 over x there. So technically the derivative of natural log x is somewhere else in the integral. So we can use integration by substitution. So let's use it. So w is going to be natural log x. Now why do I use w instead of u? Well, you know, we have to use integration by parts later. So that's coming. Let's see. So w is natural log x. Purely that's the inside function. Derivative of natural log x is 1 over x. That means what is dx? X dw. Okay, so let's replace. Now this is w square x cube. Dx is x dw. Okay, so now x and 1x cancel out. Okay, so this is w square over x square dw. All right, now you know we can't have x and w both in the integral. We have to get rid of x square. So how do you get rid of x square? Well, we go to the substitute. Okay, now we need x square and we have w is equal to natural log x. Now how are we going to do this problem? Right? How do we get rid of x square? The only help we can get is from here. Now don't try to use integration by parts here because you have a mix of variables. You can't have that here, x and w. You have to remove x square. How do you do that? Well, the only possible way, only thing that you can get help from is the substitute. That is why I said this is an extremely hard problem. How can we get the help of w is equal to natural log x to get rid of x square? Well, let me show you something. Okay, so w is natural log x. Now, base of natural log means it's e, right? Right, that is why we call it natural log x. So what is x actually? X is e to the w. Right, now you have to know logarithmic properties for this. Go back and check in your notes, in your calculus notes, or Google the logarithmic properties. I reverse the statement. So w is equal to natural log x is same as x is equal to ew. So what is x square? Is it ew square? No, x square means x times x, right? So EW times EW is e to the 2w. So x square is e to the 2w. Okay, so w square over e to the 2w dw. All right, now I'm gonna do one more thing. I'm gonna take that e to the 2w to the numerator. It's e to the negative 2w square dw. Okay, so now we have another complicated integral. How do we integrate this? Well, you can use integration by parts. Let's use integration by parts. So u is w square because that's the algebraic function. Okay, and dv is e to the negative 2w. That's an exponential function, so it is on the bottom of the list. So of course e to the negative 2w is dv. Okay, so if you differentiate u, you get du over dx is 2w. If you integrate dv, you get e to the negative 2w over negative 2. So let's use the formula. Well, du here is 2w dx. Okay, after this problem you're gonna hate me. Okay, so let's do, this is fun. Well, I guess that's not the best choice of word, but let's say it's fun. Okay, so uv minus v integral v du. So what is u? U is w square. What is v? E to the negative 2w over negative 2 minus v is e to the negative 2w over negative 2. Du is 2w, not dx, dw. Why did I write x here? My bad. 2w dw. Okay, so let's see what we get. W square e to the negative 2w over negative 2. Negative here positive. 2 cancel out. That's good at least. W e to the negative 2w dw. Okay. Now how about this integral? Is it something that we can integrate easily? No, I am afraid not. So let's write it again. So what we have here is w square e to the negative 2w over negative 2 plus w e to the negative 2w. How do we integrate this? We have to use integration by parts again, right? Trust me, after that it's gonna stop. Okay, so if we were, let's think that w e to the negative 2w is a new integral. So our choice for u is again w. dv is e to the negative 2w dw. So if you differentiate u, with respect to w, you're going to get 1. So du is dw. So v is going to be e to the negative 2w over negative 2 if you integrate e to the negative 2w. Okay, I might need to use black color. Okay, so let's use the formula uv minus integral v du. So u is w. V is e to the negative 2w over negative 2 minus e to the negative 2w over 2 minus 2, and du is dw. Okay. W e to the negative 2w over negative 2, this is positive, right? If you integrate e to the negative 2w, you're going to get another negative. E to the negative 2w, you're going to divide by another 2. That 2 and this 2 will become 4 here, plus c. Okay, at least it stopped now. Let's try to combine the full solution because this is just the, okay, so my one note is giving me problems. So we just found the answer for this. So let's copy this term, w square e to the negative 2w over negative 2, w square e to the negative 2w over negative 2, and the rest of the answer for the rest of the integral is this. Okay, now what is our choice? What was our choice for w? What was w? W is natural log x. Okay, so let's replace that to get the final answer. Natural log x square e to the negative 2 natural log x. Wow, right, natural log x e to the negative 2 natural log x over negative 2 minus e to the negative 2 natural log x over 4 plus c. Wow, that's a problem. Okay, now what can we learn about doing these type of problems? Well, you have to use integration by substitution, then you get a less complicated problem, then you use integration by parts. So that's another trick, that's another type of hard problems. Okay, so we saw that neither method work independently. Okay, all right, so what we are going to do in the next video, so in the next video let's try to understand the meaning of LIAT rule, and let's try to summarize whole thing, everything that we learned up to now, both integration by substitution and integration by parts. Let's make a comparison and stop our integration by parts video series.